So in this case, we are going to consider another typical exam revision as we are preparing ourselves for the exams which are ahead of time. So this is a KZN province, which was actually written in September 2024 as a common test. So we are going to try by all means figure out how to attempt these typical questions as we are given. So remember to go through the instructions, the information that you are given. Read everything that you are given, all right? Especially rounding off of answers to two decimal places unless stated otherwise on that particular question. So without wasting our time, we are going to quickly go through the questions and figure out how we are given these typical questions as we do understand our term 3 according to the syllabus, but it can depend also with the province. Some other provinces, they can even ask you questions which are from your term 1, whatever that you had in your term 1, in your term 2, and also the part of your term 3. Some, they can just specifically work with the term 3 syllabus as it is. Term 3 as it is. So in this case, let's see what we are given. Question number 1. The table below shows the marks as a percentage. All right, so these are the marks as a percentage scored by 10 learners in Maths Olympiad. All right, so they are given a certain test. So the marks that are obtained out of 10, out of these learners, we are talking about 10 learners, and that is ungrouped data that we are dealing with. Remember, we've got our ungrouped data. The information is just given as it is. You're not given in form of intervals where we are given something like this from a certain value to a certain value. It is not in that consideration. That is ungrouped. So the first part we are given, 1.1, was to calculate the mean mark of the data, the mean. So we do understand the mean is simply the sum of terms over the number of terms. This one is a direct part. So the mean, remember, I told you guys that's the sum of terms over the number of terms. So we are supposed to add all the terms that we're given. Add everything, the sum. That is add. So we are going to obtain 705 over what? And the number of terms as we are given, that is what? That is 10. So that was going to give us the mean of 70.5 from our calculation. All right. Remember, we can also determine the mean direct from the calculator. So let us also verify with the calculator since we are going to need 1.2. Write down the standard deviation for the above date. As you can see, the standard deviation is needed. So let us just insert our values and see. Let's start with the mean. So this is it. Go to the mod. All right, so we're gonna need the mod. Then we're gonna need number 2. That's 3. Then number 1. Okay, then let's insert our values. So we've got 65 is equal to, so we're gonna insert the values as we are given them. So that's 65. All right, we move on to another value, which is 59. So that's 59 is equal to, all right, we move on to 79. So that's 79 is equal to, then we move on to 86. 86. All right, then we move on to 48. That's 48. All right, we also have 94. And we also have this one, 74. Okay, and the 51. So here the order is not important. Just insert the values as they are. 66. Okay, then also we have got 80. Okay, so insert your values as they are. Then we can cancel this. All right, so let us cancel from this one, AC. So we're gonna need to cancel Just press that one, then shift 1. Okay, then let's go to number 4. So if it is for the mean, that is number 2. So 2 is equal to what? That's 70.2. All right, is there a value? Let's check our values here. Let's go back. That's so when inserting your values, you must be very careful that you do not miss any of the values with 65, 59, all right, 79, 86, and 48, 94, okay, 77, and 51, 66, and we also have 80 there. Okay, let's see. So that's shift 1 and number 4, then 2, which is equal to 70.5. So just make sure when inserting the values, just your calculator be very careful. Then, so this is a consideration that you must put into before you determine or state the standard deviation. Right? 1.2, yes, we were supposed to just write down this one. They are not even, it's not about calculating there. So when you verified that the mean is correct, as you can see it from your calculator, it is the same thing. Therefore, continue finding your standard deviation. Not to say when you use your calculator, you find a different value of mean, then you continue from that information. No. Because you have an answer there that you are comparing to. All right, so let us use our calculator. Just cancel this part. All right, then we're gonna need shift 1. All right, so 4, that's our standard deviation, which is what? Which is 3. So 3 is equal to what? Can even round off to 2 decimal places. Let's see. That's gonna be 14,38. All right, so our standard deviation is 14,38. So this is what you're going to have. Then on another part, we are given 1.3. Calculate the number of marks. How many marks do we have there? How many? That lie within one standard deviation. All right? They do lie within one standard, within one standard deviation. All right, so remember this one is also direct, guys. I talked about this to say when it is within, first of all, we are going to need the interval within a certain limit. It is within a certain limit. So that's within what? We are going to take the mean minus one standard deviation. So it's actually a 1 that we are using here. So there is no effect, guys. All right. Then the other part is going to be mean plus one standard deviation again. So within this interval. So remember we calculated our mean. In this case, we obtained it was 70,5. So we're just gonna substitute into this. So that's 70,5 minus one standard deviation, which is 14,38. All right. Then we're gonna add 70,5 plus one standard deviation, 14,38 again. So that's in this simplification, subtracting these two, we're going to obtain 56,12. All right, then if we add these two, we're going to obtain 84,88. So this is what we're going to obtain. So in our simplification, we are saying the values or the marks that we need, they are within this interval, this one standard deviation. This is our interval of one standard deviation from the mean. So within these values, which values are we going to, or are we talking about? That are more than 56,12. As you can see the decimals, so we're starting about numbers that are greater than that. 56,12. Talking of whole numbers, we talk about 57, 58, 59, and so on. But these numbers are supposed to be on this data. So let's take anything that is above, but it must be less than 84, 48, 84,88. Meaning to say, when something is less than 84,88, this is what we have. So this is 84,88. There is 84 as a whole number there. There is 85 on this other side. So numbers that are less than 84,88. We're talking about 84 is supposed to be there. 84, 83, and so on, and so on. So these are the numbers that we need, all right? So let's check, all right? Let's check from our table. 65, is it within this interval? Yes, it is found within. 59, it is also within. 79, it is also within. As we can see, 86 is more than 84,88. It is more than this. We're talking about numbers such as 85 going up, 85, 86. It is more than, so we do not need this. But if they say those marks which are outside of this, we're going to take this one. But they say it within. This one is outside. All right, 48. 48 is less than 56. It is outside again, so you cannot take this. 94 is greater than 84. We cannot take this. It's outside. 77, it is within. All right. 51, it is outside. It is less than this, so it is outside this one. 66 is within. 80 is also within. So these are the ones that are within. How many are they? That is 1, 2, 3, 4, 5, 6. We have got 6 of these marks which are within. So I say therefore 6 marks. All right, so that is 6 marks lie within one standard deviation. They lie within one standard deviation. All right, within one standard deviation. All right, one standard deviation of the mean. All right, of the mean. Just conclude that statement of the mean. One standard deviation, okay, of what? Of the mean. So this is what you simply need on your simplification. All right, let's consider another part of the question, which is on 1.4. We are given that 2 learners were omitted. They were skipped as the marks were being taken. 2 learners were not considered from the original set of data. From the original one, they were not considered. Then we are given that their scores were X and 58. Those scores for the 2 learners which were being omitted. So when the scores of these 2 learners are included with the original set where they were excluded before, now when they are being considered as part of the set of data, then the new mean is now 67,5. Calculate the value of X. So this is what we have, guys. The data before, which is our original set. The original set of what? Of data. In this case of our 1.4. The number of elements was 10, as we are given. There were 10 learners. When these 2 were not included, our n was equal to 10. The mean, we also calculated the mean. Remember, we have got the mean, which is, for in this case, it is not important, but remember, we calculated the mean that was 70.5. And that mean, when we calculated, remember, the sum of terms, when we added this, it was from the sum of terms of 705 over 10. So we have the sum of terms, this one, 705. From that original data that we had before, we have got the sum of terms, which is 705. For the new data that we are given now, they gave us as a combined, the new mean here, when they say the new mean, it is a combined situation. It is not like we've got original, we've got the first and second. The new data that we are talking about, the new set of data, it is combined. They combined the two, the original and those ones that were being excluded before. They now took them now together, combined situation that we are now having. So on that combined situation, we are told of the mean. We are given that. The mean of that combined data is what? 67,5. That is the combined mean, which is the new mean. This one. This is the new mean. But this new mean, where was it taken from? When all of them are combined, the 10 that were originally given and those two learners that were now added, because remember they were omitted before. So on the new set of data, our n is going to be 10 plus 2. Remember there were 10 learners before. When 2 were not included, we're having 10. So now we're going to take them into consideration because the new mean of the new data, this one, it is using those learners. They are now part of the what? Of the set, because you're told they are now included here. So that's, we've got 12. So the question is, what is going to be the value of x if we are given a mean of 67,5 as our new mean? The same mean that we calculated as the sum of terms over the number of terms, but we are now considering to say this is the new mean. And the sum of terms here is supposed to be of a combined situation where we must consider the original set and those two learners that were included. So we can form an equation from there. As we can see, we can form an equation to say the new mean that we are given, 67,5, is equal to what? The sum of terms for combined situation where we have got 705 that we started with, plus, remember this one, it is the sum of what? Sum of 10 terms that were given before. The 10 learners, this is their sum. But there is supposed to be what? The two learners that were added for us to obtain the new mean, this one. It is because of these two learners, the one that was x and the other one that was what? 58. So we take these ones into consideration, the x and what? The 58. So these two are the ones that were omitted before. So now they are added into our set. Out of what? The n number of terms when they are combined together. That is going to be what? 12. We are no longer going back to this. We have added 2 learners. So out of 10, we add. So now it is now out of what? Out of 12. So we formed an equation, guys, that we must solve for x. So let's solve for x and see what are we going to have at the end. So this is same as over 1. Okay, let's just start by combining the numerator here. So you can see the alike terms, 705 and 58. Just add these two, 705 and 58. This was going to give us 763. All right, so that's 763 plus x. Everything over 12, all right? As you can see, we can do cross multiply fraction to a fraction. So cross multiply, this multiplies here, this multiplies here. So that's 12 times 67,5, which is 810, 1 multiplies everything here, so that's 763 plus x. There is no effect when you're multiplying by 1, so thus we can solve for x. Take this to the other side. That's x is going to be 810 minus 763. You're supposed to subtract, which is going to give us what? 47. That is the idea there. So questions can be of this nature. Questions can be of this nature. You must formulate an equation from what you are given. Solve for x. So in our case, there are 2 learners who were not included, and the mean was being calculated and we obtained a certain mean. But now when they are now included in the set, we are given the new mean. So we work from that new mean, which is of the combined set of data, what we had before and those 2 learners. All right, so another section on question number 2, we are given this information that the ages of people who attended a musical concert was recorded and the information was summarized in the frequency table below. All right, so it was a musical concert, and out of that, this is the information that we are given, that is the age group X and also the number of people. So 2.1, it was complete the cumulative frequency column in the table provided on diagram sheet 1. So this was the part of the diagram sheet. So they wanted us to complete here. As we can see, it is the cumulative frequencies. How do we fill our cumulative frequency column? Remember, cumulative is increasing. We start with the first frequency that you're given, the number of people representing what frequency. So you start with this one as it is, as a 2. Then the next part, it is added. We are increasing. We are at 2. We are going to increase the next one, which is 8. To increase is to add. So we add 2 plus this one, which in the next one. 2 plus what? 6. Whatever that we get is supposed to be written here. So that's 2 plus 6, which is what? Which is 8. With the same sense, 8 to 12. We add these 2, whatever that you're going to get, you write here. So that's 8 plus 12. That was going to give us a 20. Then 20 plus 24, which was going to give us a 44. 44 adds 36. That was going to give us 80. 80 adds to 24. And that was going to give us 104. We add these 2. That was going to give us 120. 120 plus 10, that was going to give us 130. All right, just like that. So you can actually trace out how to fill this table. All right, that's just like that. So the first question, it was to complete that table as we are given. Then after completing the table, on question 2.2, use the grid provided in the diagram sheet 1 to draw an ogive, the cumulative frequency curve, the cumulative frequency graph, to represent this data that we are given, to represent the given data. So the question is, how are we going to have that? A cumulative frequency curve, the ogive, remember, a straight S like that, from the upper classes versus what? The cumulative frequencies. So you're going to mark these upper classes versus their cumulative frequencies. So we ignore these frequencies, this one. Ignore this part. This is what we want, cumulative frequency. So as we can see, the first value here is 2 on our cumulative frequency. We need our graph to start from the ground. So to have our graph from the ground, this is what we are going to do. Remember I said you will work with the first class. Then you are going to take the lower class of that first class. You consider it as an upper class to say x is less than or equal to 18 with a cumulative frequency of 0 so that our graph can start from 0. So these points are the ones that you're going to be taking, guys. Upper classes, x is less than or equal to 22, x is less than or equal to 26, x is less than or equal to the upper classes versus their cumulative frequencies. So each is supposed to correspond to its cumulative frequency. So let us consider this. So that is 18 versus what? Versus a 0. So you're going to mark your points on the graph. 18 according to what you're given. That's 18. Already we're already given these points, 14, 18, 22, and so on. So you can simply work with the points. 18 versus a 0. Then we consider another point as they are. That is 22 versus a 2. Where are we having 22? We are already given. So 22 is approximately between 0 and 4. So you're going to mark your point and so on and so on. So we move on. 26 versus 8. We are also given on this part. The 26 is already given. So you mark your points and so on. So with the points, join, we have got what? A smooth, straight S that we is representing what? A cumulative frequency curve, an ogive. So you're supposed to join the points in a smooth way. All right. So that is an ogive. And 2.3, write down the model class of the data. Remember the model class, the one that has the highest frequency. Which class is it that has got the highest frequency? So you just consider on your frequencies this time. All right, on your frequencies, on these frequencies that we had, we consider to say which one is the highest on our frequencies. The highest is 36. So which class is it that has got that highest frequency? That is from 34 to 38. So we're going to write this one as it is. All right, that is from 34 to 38 as it is. So that was going to be x is greater than 34, but the same x is less than or equal to 38, where we have got the highest frequency. Then 2.4, the youth are regarded as people below the age of 35. So when we say someone is a youth, we're talking about someone who is less than 35 years. So we are saying as the youth are regarded as the age that is below 35, what percentage of youth attended the concert? All right. So at the age of 35, we consider what is it? Let's consider 35. So according to the graph here, guys, as you can see, there's a difference of 4 units between here. So to actually locate the 35 here, it is something that is difficult, but you approximate where you can have your 35. As you can see, it's 4 units. So you can just say in between here, it is 36, between 34 and 38. So 35 is going to be in between 36 and 34 and 36, in between. So let's say this is where we've got our 35. Then we're going to take that point to the graph. All right. So let's just try to have something from 35 straight to the graph. So this is your 35. You take it straight to the graph like this. So the corresponding point that we are seeing at 35. So in this case of mine, it was somewhere here. It was somewhere in between at 52 there. All right. This one. So it's going to be, according to your graph, guys, maybe it can be somewhere at 54, 56, approximately. All right. But in my case, it's just going to be at 52. So that's 35 in this case corresponds to 52. But we are told that a youth is someone who is below 35. So below, that is the age going down. In this case, this 35 going down. So if we are talking about that, we are talking about this interval also going down. So that's 52 minus what? The minimum that we can have is what? It's 0. So the difference is what? Is 52. So there are 52 of them. But the question is not asking about the number of youths that were there. It is asking about the percentage. What percentage of these 52 that we are given? So what is the percentage? So as a percentage, that's 52 out of what? The total, as we have everything, the sum is here. This is the total, 1/3. All right, so you can multiply to 100% as a percentage now. So this is the percentage of the youth which attended the given concert. So as a percentage, that was going to be 40%. So here, guys, you might have any other value which is not 52. So use the value that you're obtaining from your graph. All right, guys, as you can see, it was a typical approximation that you are to make as you are given. These guys is not, as you can see, the part that is in between here. We cannot exactly tell to say it, which point exists. So you just approximate in between. Say, okay, this can be somewhere here, 36. So somewhere in between, this is 35. Then you take straight to the graph. The corresponding value, the difference. If it was any certain value which is more than 35 years, you are going to take the difference from the top. You consider the difference from what we had, that's from 52 from the top. If they say, if it was something that is above, let's say it is above what? 35. So you consider the section that is on top. Below, you consider the section of that 35. Below, you consider this section. That is how you can attempt these typical questions. You can attempt as many questions as you can. All right, let us consider another part of the question, which is question number 3, which was a question based on probability. Given two events, A and B, such that the probability of not A is 0.55, the probability of B being 0.4, the probability of A or B being 0.67. Then from the given information, are these events that we are given independent events? Justify your answer with relevant calculations. Okay? Given that two events, they are independent, we do understand that for events A and B to be independent, if they are independent events, the condition is the probability of A and B is supposed to be exactly equal to the probability of A times the probability of B. This is our condition of independent events. Dependent, these two, they cannot be equal. Remember our introduction on our probability. So meaning to say that if we have got A and B, we also have probability of A, probability of, just multiply and find the answers, guys. But is it the case? Look at the number of marks, 5 marks. It is certain that there is something that we must work out there. So what is it that we must work out? Because this is a condition that we want to prove. We do not have probability of A and B. We do not even have probability of B. So that we can have, that is probability of what? Of A, sorry, here, this one. The probability of A, this one is not there. So that we can find the product of these two. So thus you are forced to find these two. Probability of A, probability of A and B. So let's start by finding the probability of A. Why probability of A? Remember from the complementary condition, from the complementary events, we do understand that if I am given a probability of not A complement, I can find probability of A. Remember that probability of A plus the probability of what is not in A is supposed to give us a 1. So thus, in this case, we can play around with our formula, find this, make it the subject of the formula. So PA is equal to 1. We take this one to the other side, that's a minus probability not A. So this is what we have. So we have got the probability of what is not in A. We have got that probability. So with this condition, we are going to consider substituting probability of A, all right, is equal to 1 minus P not A. What is not in A, that is what? 0.55. So we must determine that one. So with the information that we are given, we now have the probability of what is in A, meaning to say the remaining part. All right, the probability of what is in A, that is the remaining of what was not in A. And that was going to give us 0.45. All right, that is 0.45, this one. All right. So with this information, let us try now to determine what is in A and B, as it is also needed here. So there we can just multiply and see your answers, but let us have the probability of what is in A and B. So which part can we use? Remember, there is probability of A or B. Probability of A or B. We do understand from our addition, probability of A or B is supposed to be equal to probability of A plus probability of B minus the probability of A and B. This is what we understand. So thus we can play around and substitute, since we have got this probability of A or B, probability of A, probability of B is there. So we're simply going to make what we need the subject. So let's take this one to the other side of the equation, make it a positive. So P, A, and B is going to be equal to what? What is remaining on the right hand side? Probability of A plus probability of B. We take A or B to the right hand side. So that's going to be a negative A or B. Just like that. Remember your change of subject. So substituting what we calculated before, the probability of A here, which is 0.45, we have got this one. And probability of B, which is already given from our information. We already have this one, 0.4. All right, so that's 0.4. Okay, 0.4 as it is. Okay, no problem. Minus probability of A or B. We also have this one. We are given A or B, which is 0.67. So we're going to subtract 0.67. All right, so this is going to give us the probability of A and B. So probability of A and B is equal to, if we are going to add everything, that was going to give us 0.18. That's 0.18. So the question here is for us to prove that, or to give a verification to verify if this is true. Are these events independent? Since a condition of independent events states that probability of A and B is equal to the product of these, we have got the probability of A and B now. So what is it that we must prove? Let's multiply. What is in A times the probability of what is in B. If we are obtaining same answers, then therefore they are independent. If we are obtaining different answers, it means they are not. All right, so now let us find this. Probability of A times probability of B. So finding, multiplying these, probability of A, remember we've got this one already calculated, 0.45 times that one of B, which is 0.4. So that was going to give us, all right, 0.18. So as we can see, we are obtaining same answers. The probability of A and B, and that probability of A times probability of B, this one, they are exactly the same. It is exactly the same. Probability of A and B is exactly equal to that of A times that one of B. So therefore, A and B, or events A and B, are independent events. They are independent events. So that is a condition that you are supposed to actually understand as part of your syllabus as you are working with events. Know each and every part, inclusive, exclusive, independent, dependent events. All right. On another section, we are given that a survey was done among 100 tourists. All right. They are given 100 tourists. So out of them, we are given to find out which city in South Africa they loved during their visit. They chose from Johannesburg, that is the Durban part, and also the Cape Town. The results of the survey are listed below. All right, so as we are given this information, then the above information is represented in a partially completed Venn diagram below. That is, the Venn diagram is not complete. So try to study out the information that you are given from the Venn diagram and what you are given originally. So in this case, if we are to consider, we can see that some of the values are given, some are not on our Venn diagram. From that information that we're given, some are presented, some they are not. So let's figure out. We are told that there are 100 tourists. So meaning to say our sample space, we are talking about 100 of them. Then from that, we are given some they chose from Johannesburg, some they chose from Durban, some they chose from what? From Cape Town. All right. 17 said they loved all three cities. All three. Is it exactly what we are given? All three. This is exactly what we are given there. 17. Then we move on to another part. 30 said they loved Durban and Cape Town. There are two here. Durban and Cape Town. There is no only here. It's not there. So meaning to say we're talking about a combined part of Durban and Cape Town. Durban here and Cape Town. So in between here. Durban and Cape Town here. This is where we are given the 30. In between. It is not here. Here. No, no, no. If there was only, then we're going to take this part. Remember from our sets. So the 30 is in between Durban and Cape Town. Then we also have 27. They loved Johannesburg and Cape Town. There is no only there. So the 27 is also in between Johannesburg and Cape Town. In between here. In between. That is where the 27 is. So we've got 27 here. All right. Then another part is 52 said they loved Deben. 52. The whole set here, this is our Deben D, this one. The whole set as we see it, this one, is 52. Okay. Then 9 say they loved only take note, Johannesburg and Deben. Only. So we have to consider where there is Johannesburg and Deben only, which is this section. This is the only section of the two. Is the two, but only the two, not with Cape Town. The Cape Town is not included. So it's a both, but which is considered as an only, which is same as this part of B, which represents what? The Durban and Cape Town only. Then we talk about this A, which represents what? Johannesburg and Cape Town only, when they put that only. All right? So 12, they loved Johannesburg only. Which part represents Johannesburg only? This section here. Without anything from Durban, without anything from Cape Town. So this is the section of Johannesburg only, which is the 12. Okay. Then another part, 9 say they loved what? Cape Town only, which is also given. The Cape Town here only, which is the 9 that is here. All right. So this is our information that we have. And from that information and the diagram, the question on 3.21 was to write down the values of A, B, E, and F. How can we determine these from that information that we are given? So if we check, the A can be determined. All right, let me just try to have it here. If you understand the Venn diagrams, guys, this one is just going to be an easier part. 3.21. For us to determine A, remember here, there are 27 that we are given for Johannesburg and Cape Town. We are told that there are 27. So out of 27, that is where we have got A and 17. So we can determine A from there because the sum of those two, A and 17, must give us 27. So A is simply equal to what? 27 minus 17, which was going to give us a 10. All right, so A is 10. The same with the B. Remember I told about this, Durban and Cape Town, which is what? 30. That is the 30 that we see here. The 30, it covers these two. So if I add B and 17, I'm supposed to obtain a 30. So from there I can obtain B. 30 minus what? 17. That was going to give us 13. So B here is 13. I can also find E. From where? From the set of Durban, we are told there are 52 of them. So adding everything that we see, if we add the 9, this one, the 17, everything that we see, the 13, which is representing the B that we calculated, and the E here, if we add everything, that's Durban. That's the set of Durban. How many are we having there? 52. So we have an equation that we can solve for E. That's simply an equivalence to say E is equal to 52 minus, we take the 9 to the other side, the 17, the 13. That was simply a condition. Or simply to say 52 minus the sum of 9, 17, and 13. The way that you understand, guys, it's an equation, so you can work it the way that you want. So that was going to be 52 minus 39, which is going to give us 13. So E is also equal to 13, just like B, just like this B. So our E was 13. We can also determine the letter F, which is outside. Now that we have got everything being filled in on our diagram, we know that the sample space of all is 100 of everything that we are given there. So we are simply going to find f from what? From 100. So f is equal to 100 minus the sum of everything that is inside of the given set. Everything. So there is a 12 plus there is a 9 plus there is a 17 plus there is a 10 here representing A. All right, there is a 10 which is representing letter A, plus there is a 13 representing B. There is also a 13 here which represents E. All right, this one represents E. Then there is a 9. All right, there's a 9 this one. Then there's another 9 this one plus a 9. So thus, if we subtract everything from 100, we're going to obtain the letter F, which is remaining there. So that's 100 minus the sum of these. That was the sum of 83. So 100 minus 83 was going to give us 17. Okay, so that's it. So we have got our F outside of these sets. It's what? It's 17. So questions can be of this nature. Yeah, it can be like that. You just have to be very careful, understand your Venn diagrams, understand all sections actually. Then you're being asked this time to determine or to calculate the probability that a tourist is selected at random, but that tourist loved Cape Town or both Johannesburg and Durban. Both. So there's a condition of we have or and where is both and. So in terms of a presentation, it was supposed to be like this: Cape Town. Then we have got the union, or simply means what? Union. But the union part is supposed to be of the two combined. There is both end there. Both end. Remember both end. Meaning to say we are simply talking about what? An intersection of Johannesburg and Durban. There's an intersection there. So this is our condition. So it is the element C union J intersection D. So in terms of probability, we are saying it is the probability of this. If we can find the presentation which represents this set, C union J intersection D. Which set is it that we are talking about? Which part of the set are we talking about? Here, which part of the set? All right, it is like this, guys. If you understand these sets, guys, it is easier this way. Let me just try to have a sketch. This is it. This is how you answer this one. You take your J, this is your D, this is your C. All right, so this is our J, D, C. So remember, we need C union J intersection D. This is what we need, J intersection D. This is what we want. So there is a union here. Union means combine. Remember, union, you combine. So you just wait about this. First, start with these two. J intersection D. What does it mean? J intersect is the intersection of J and D. This is our J. This is our D. So the intersection is here. This is J intersection D. This one. This is J intersection D. We are not given to say J intersection D only. It is J intersection D. So you take everything that you see where the J part is and the D part is where they combine here in between. All right, that's our J intersection D. But it must be combined to C. Union means combine with the C. So this is our set C, this one. Let's shed our set C. Everything that we see in C. This is our set C, this one. So as we can see, if we take C and we combine it to J intersection D like this is the whole part that we are going to need at the end. This section that is presented, this piece. Every shaded part that we see, because of the union that we see. Union means combine. So meaning to say, on our solution, we are going to take these ones as part of our solution. We're going to take this part that is shaded, the A, which is representing the 10, the 17, the 9, this section here. This is the section that I'm talking about here on our diagram. This one. This is the section that we're going to take. Every part of this section. So first of all, locate the position, locate where it is, where is that presentation found, like in terms of the presentation that you're given. Where are those elements? Where are they found? Those elements, they're here. This is the indication. Because of the union, you must combine. All right. So once you know how to locate these guys, you're done. So let's find our probability, as the question here is not about the number of elements. The question is we are supposed to find the probability. All right. So that's 3.22. All right. So the probability of this C union, or you can just write O there. That's J intersection D. All right, like this. Or you can just, here we can just write and. All right. So it is going to be what? We are supposed to add everything that we see. This is the indication. So on sets, you take as it is. There is what? A 9 here. So let's take, there's a 9 plus, there is a 17. There is a 10 representing A. There is a 13 representing B. There is a 9 which is representing what? C only. There is a 9 there. So you add everything over the total of the sample space, 100 tourists. So that was the equation. That was the part of our simplification. I mean, locate where the elements are from your Venn diagram. Locate where are they found. If you can say, okay, these are the elements, then combine them together out of what is in the sample space. So that was going to give us a total of 58 over 100 as a decimal. That's 0.58. You can just divide on your calculator. That's 0.58. You can have it as a fraction, as a reduced value. 58. All right, let's go back to the compact mode, which is 58 over what? Over 100. That is 29 out of 50, or 29 over 50, or you can have it as a decimal. It is up to you. So this is how these questions given as. Just try to revise as many questions as you can. Do as many questions as you can. As you are preparing for the exams, you must work out as many questions. All right. So another part, 3.3, we are given a condition which is based back to our probability. We are still back on our probability. So there is, let's see, we had a small box. All right. There's a certain lady which has a small box of 80 Smarties sweets. So there are 80 of them. Okay. And out of that, we are given this information and that other information. And the question 3.31, it was how many red Smarties were in the box at the beginning. So it is for us to answer that question 3.31, we must know how many of each color that we are given, for us to know the ones that are red. So here is where we are going to obtain our answers from, because we are given that there is a 40% which is green, there is 3 over 20 which is blue, and the remainder is red. So let's start with green. So the green, 40% of what? Of the Smarties, 80. Remember, the Smarties, the total is 80. So 40%, 40 over 100 times 80. That was going to give us the green, which is 32. So 32, they are green. Then we move on to the next one, which is the blue. 3 out of 20, 3 over 20 for blue. 3 out of 20 of them. 3 out of what? Of these 80 sweets that were given before. So 3 out of 20 times that 80, this was going to give us 12. So 12, they are blue. And the remainder is red. The remainder, what is remaining? That's our red. It represents the remainder out of the total of 100. We must subtract the 2 that we have, 32 for green and 12 for what? For blue. We must subtract these 2 from 80. That's the remainder part, our red. So meaning to say our red at the end, it was going to give us 36. So there are 36 sweets which are red in color. All right. Then represent the above situation by means of a tree diagram. Indicate the possible associated with each branch and the possible outcomes. So to answer this question, we go back here and relate our information as it is given. So let us try to understand. Remember, we calculated these. So let me just have these ones aside so that we can have some space here. There is a total of 80. Our total of 80. And out of this total, we saw that green, the total considered, so that's 3.32. So for green, we calculated these ones and we say they are 32. All right. Then blue, we said they are 12. And red, they are what? 36. So on a tree diagram, you must consider a condition of with or without replacement. So what is happening here? Nelisio picks a smarty out of the box. Right? She took one out of the box. Then what happened? Takes note of the color. So after taking the sweet, she looks into the color, takes note of the color. Okay, it is red, it is blue, it is green. She takes note of the color. Not only that, and then eats it. And then eats it. So in your understanding, is that a replaceable thing that we are talking about? No. She has eaten the sweet here. So meaning to say, we have out of the box that she had, the small box, we have a reduction in terms of the sweets. So that's a without replacement. She's not replacing it back. She then picks out a second Smartie and notes the color before eating it. Nothing is being replaced. Every part that she's taking, she just notes the color, then she eats. So if we are to consider this, we are saying that's without replacement. Without replacement here. That's a without replacement. With replacement, you note the color, then you place back into the box. That is a with replacement. But this one, she was to eat each part. But it happened what? Twice, remember? She took the first, not it, and eats. Then she picks another second one. That is where so it happened twice. So we've got the first pick where she can pick green, she can pick blue, she can pick red. The first pick, she can pick any of these three colors: green, blue, or red. That's our first pick. We are supposed to use the three colors as they are. This is our first pick. The second pick, because remember, she ate the sweet now. Then she has to pick again from the same three. So meaning to say it was going to branch again. This is our second pick. Same condition, green, blue, red. Same here with the blue. It was going to branch, giving us the same thing. Blue, as it is here, green, blue, and so on. So this is green, blue, red. All right, let me just put this one, the last one, the red here. It branches as it is, giving us three, just like before. All right, green, blue, red, green, blue, red, as it is. So these are the outcomes that we are having. So remember, we had got the first pick, then the second pick, and the issue of our possible outcomes now. As we take this green to what? To green. So it can be green to green. It can be green to what? To blue. It can be green to red. We are done with the first branch. We move on to this one for blue. It can be blue to green. So it can be blue going to green. It can be blue going to blue. All right. It can be blue going to red. Okay. We are done with this one. We move on to the branch of red. So it can be red to green. All right. So it can be red to green. It can be red going to blue. It can be red to red. So these are our possible outcomes. On without replacement condition, without, you do not return whatever that you take. So the first one, to pick green, it is as it is. The first condition, guys, the first pick, you just take as it is. The green as it is out of the total. Remember, our total is what? 80. So green, it was 32 out of 80. All right, 32 out of 80. The blue as it is, 12 out of 80. The red as it is, 36 out of 80. So this is it now about a without replacement. It affects the branch that you start with. The green affects the green. You pick a green, you eat that. So it means it affects its total. There were 32 that are green. So when you take and do not replace, it affects the total for that green only. So it means if it was 32, we're going to have what? If it was 32, 32 minus 1, they are now 31. Out of what? The whole total of the box. The box, it was having 80 sweets. But once you do not replace, it means for the second pick, the sweets, they are now 79 because you have taken one. So if it was a green, it was going to be 31 out of what? 79. It affects even the total. Whereas the rest, they remain as they were here originally. But the total is affected. So meaning to say, the blue, it will remain as it is. Its total is 12. The total, it will remain 12 out of the 79 is the one that is affected, because the box, here it is about the box, the total in the box, it's what? 79. Red is not affected on that branch, so it remains as it is, 36, but the total is affected out of 79. That's the branch of green affected. Same thing with blue. When blue is affected, it is being taken. when we consider to say we are picking blue, if you then pick another blue, like blue, then we pick another blue like this, it is the blue that is going to be affected. How many were they? There were 12. So we have taken one. It means their total is affected. They are now 11 out of the second, guys. It's always 79. So that's 7 out of 79. Whereas the rest, they remain as they were, green from its original as it was. It was what? 32. Out of the total, guys, is the one that is affected out of 79. The red remains as it was before. How many were they? 36. It is only the total affected, 79. So blue to blue. Same thing with the red. It is red to red. Same thing with this red. It is, you pick a red, then you pick a red. That's where the effect is. They were 36. So now they are what? 35. 36 minus 1. 35 out of what? The total for the second part, the total is always out of what? 79. It has been affected. So it's red to red. Whereas the rest, they remain as they were before. Meaning to say, the blue remains as it was. How many were there? 12. So it is 12 out of 79. The green as it was before, 32, but out of what? Out of 79. So that is without replacement. Red to red, blue to blue, green to green. They are totals. I mean, they are totals from one branch to another. Whereas the rest is everything out of the second total, which is what? 79. Once you pick one, you remain with 79. So it's like a possible outcome condition to say what will be happening when this happens, what is going to happen later on. Okay, anyways, these are our outcomes. Our diagram is there. So that is it. All right, let's see. Okay, here it was just the Venn diagrams. Then 3.33, which is now calculate the probability that Nelisiwe will pick two Smarties of the same color. There are two that are being picked, and they are of the same color. Which colors are we talking about? Green, blue, red. So if we are talking about the same color, remember, it happened twice, 2 times, first and second. But we need, when we are referring to two colors in terms of the probability that are the same. So which one? It can be green, green, same color for the two. It can be blue, blue, same color. It can be red, red, same color. So in terms of the probability, we need probability of GG plus, remember, as you move outcomes, you add outcomes. This one to this one to this one. So plus probability of blue, blue, plus probability of red, red. But along these, we must multiply along the G to G. G to G like this. You multiply. So that's 32 out of 80 times what? 31 out of 79. You multiply along, all right, plus the BB. Again, you do the same. B to B like this. So that's 12 out of 80. 12 over 80 times 11 over 79. Just like that. Same thing, red to red. This is red to red here. So that's 36 out of 80. 36, all right. So that's plus 36 over 80 times 35 over 79 times 35 over what? 79, as it is in each case. So you can actually Use your calculator, guys. Simplify everything. That was going to give us 149 over 395. And as a decimal, that's 0.32 to 2 decimal places. Remember the instruction of the questions before that our answers should be given to 2 decimal places. So that is how these questions can be given, as you just have to figure out type of a question. Like as you can see, it was it was a lot to consider on one question, but you must be careful as you answer your questions. Then question 4, which is part of our financial mathematics. 4.1, we are given a condition of a growth. This is a growth here. The population of a fish, the population of fish in a tank. Populations on the growth. So it can be growth and what? Growth and decay. So we are given that the population was 5,591 at the end of 2014 and end of 2022. The population of the fish grew to 6,423. As we can see, this is bigger than, so that's an increase. So when it is an increase, it's a growth where you use the compound interest formula. All right, you use the compound interest formula. Compound interest. It's a growth that you're talking about. So the question here, it was calculate the average annual rate which the population of fish grew over what? Over these 8 years. So we're given the number of years. That's okay. Let's just be straightforward. So as you use the compound interest formula, A, everything, guys, okay? A is equal to P into 1 plus I to the exponent of N. Everything that we see here can be used as we use it under financial condition to say this is a financial statement. Yes, about growth, but we can use the formula for finance. P is the accumulated amount. In this case, is the increased value of the population. Over the 8 years, the population grew to what? 6,423. The P representing the principal amount. In this case, you're talking about the original population that you started with. You started with what? Originally 5,591 into 1 plus the rate at which that population is increasing, you do not know. But you're given the number of years, which is what is 8. Annual rate per annum. That's it. So meaning to say there's no effect of any compounding. There was what? Annual. So let's find I. There's now solving, guys. We can get rid of this. Just divide by 5,591. All right. As we are dividing here, we can also start with this side, guys. It's going to be 1 plus I to the exponent of 8, which is equal to 6,423 over what? That's 5,591. Okay. There is the I that we want, which is raised to the exponent of 8. There's that part of the bracket. So get rid of exponent of 8. That's the eighth root of that one, eighth root of this. Or you raise to the exponent of 1 over 8. So the eighth root of this is simply neutralizing the exponent. So you're left with 1 plus what? 1 plus I. So if we've got 1 plus I, which is equal to this eighth root of that part, which is the eighth root, or let me just write 6,423 over 5,591 like this, we can find the interest. Which is the annual rate at which that population is increasing. So take 1 to the other side, it was going to be a minus, all right? So meaning to say I is equal to the eighth root of 6,423 over this All right, then we subtract 1 from there. So whatever that we're going to get here was going to give us the decimal part as a percentage. Simply take whatever that you're obtaining on your calculator, multiply it to 100%. You are going to obtain the percentage from there. So it was 0,01749 times 100%, which was going to give us 1,75% to 2 decimal places. So questions can be of this nature. Questions can be like that. 4.2, we are given to convert a nominal interest rate of 9% per annum, which has been compounded halfly in terms of half yearly, to an effective interest rate. So convert the nominal interest rate of 9% to an effective interest rate when it is being compounded what? Half yearly. So remember, in this case, there is a formula that connects the two, the nominal interest and the effective. We do understand 1 plus I effective is equal to 1 plus I nominal, which is over k to the exponent of k, where k is the compounding. So us, we need to find what? The effective interest rate, this one. So just substitute, guys, everything was direct there. So that's 1 plus, if we are to substitute, all right, that's 1 plus I effective, all right? Let's have it like this, which is equal to 1 plus the nominal, that's 9% per annum compounded half yearly, meaning to say we consider 2 times half yearly there, 2 times. So our K is 2. So it was going to be percentage over 100, which is 0,09. All right, as a decimal, 0,09 over 2. Then K is our compounding as it is, which is what? Which is 2. As it is. All right, so let's find this I effective. We're going to take the 1 to the other side. It was going to be a negative, just like the previous case. So that's 1 plus 0,09 over 2 to the exponent of 2 minus 1. Whatever that you're obtaining here, simply multiply it by what? 100%, because you need the percentage of it. The interest rate, which is the effective rate, as a percentage per annum. All right. So using your calculator, this part here in this bracket was going to give us something like, right, let's see. It was going to be something like 0,09202, something like that. So multiply to 100%. That was going to be 9,202, 2 decimal places. The effective per annum. So this is per annum. So that's how these questions can be given as for 3 marks. Just have to be very, very careful. Know exactly what you're given in terms of the information, then look for the formula that suits that given formula. Then on 4.3, we are given yet another part, which is to be done on our finance. We are given that Mr. Mukwesa owns, all right, he owns a business that makes built-in cupboards. So today he bought a board cutting machine for 250,000. Okay, that is on a current situation. Then the machine is expected to last for 6 years. The number of years when operating is supposed to last for 6 years to have value. So 4.31, calculate the scrap value, okay, of the machine in 6 years' time if it depreciates. There is a depreciation there annually on a reducing balance method. So that's we are dealing with depreciation here, guys. This one is just going to be straightforward. Remember, amount is equal to P into 1 minus I to the exponent of N when dealing with what? Reducing balance. So what is the scrap value? The value at the end of what? 6 years. So A is equal to P. Remember, principal, the amount that you started with, 250,000. All right, into 1 minus the interest, which is the annual per annum. We are given this is per annum. So it is not effect. Yearly. Divide by 100, that's 0, 0.12. All right, to the exponent of any number of years. Within how many years? Within 6 years. So this is it, guys. It was just you and your calculator. Just try to use your calculator properly. 250,000 like this. You open bracket, 1 minus 0, 0.12, close it to the exponent here of what? 6. So that's it. So this is the total, the accumulated amount. All right, let me just write my answer here. So this was going to give us 116,101,3,02. All right, which is to 2 decimal places. Then 4.32, the cost of a similar machine increases at a rate of 11. There's an increase this time. And it's being compounded what? Quarterly. Calculate the cost price of the new board cutting machine in 6 years' time. So instead, when it is new, it is getting value over the 6 years. Whereas once the machine has been bought in 6 years, it is having a reduction in terms of the value, a depreciation. So it's a type of a comparison, this one. But in this case, we are not comparing, we're just straight to the question. So what is the cost in those years? All right, so we go back. This one, it's an interest, compound interest. There is no reduction. All right, so 4.32 given our principal, 2,500. So A is equal to P into 1 plus I to the exponent of N, compound interest formula, or the principal, 250,000. 1 plus the interest rate for this one is 11%. Divide by 100, 0, 0.11. But it's being compounded what? Quarterly over 4. To the exponent number of years, 6 times the compounding 4. So that's it. So just use your calculator. You're going to get an amount of 479, 406, 53, like this. There was an increase in terms of the value. But when it is being, like when it is being used along with time, it is depreciating. But similar machine, when it is not being used, it is increasing in terms of value. So be very careful when answering your questions. What type of a condition is it that you're given? Then 4.33, we are given that Mr. Quasar will trade in, will bring the machine which is now at this value over 6 years. The machine for trade in. But is trading in for what? For a machine which is now at this value after 6 years. So the question is, calculate how much more will Mr. Mkwesa have to pay. How much more? That's a top up. Because remember, a trade-in, you bring the machine. But once when he's bringing this machine into consideration, the machine is at this price. It is depreciated. So when he's bringing it back, the machine is now at this price. The price of the machine has increased. So that top up is going to be what? All right. So 4.32. We just need the top up of the 2, which is the difference. The price that you see in the shop, which is for 79406.53 minus what is the worth of his machine after 6 years. The machine is worth 116 101.02. That is what his machine is worth after 6 years. So the difference of what he sees in the shop versus the worth of his machine. That's a trade in. So that was going to give us a difference of 363 305.51 to 2 decimal places. All right. So that's the top up that he must pay. Yeah. He has got what? A top up. So if he has got this amount, he can trade in for a new machine. He is no longer buying the new machine at the price, this one. No. He's buying it at a lesser price because of what? That trade-in concept. So the question now further tells us that Mr. Kwesa opened an investment account. He opened an investment. He's supposed to keep a certain amount of money so that it can accumulate over a certain period of time. That pays an interest rate of 12.25% per annum compounded monthly. 12. How much in this case should he invest? How much is supposed to invest in this bank today so that it will accumulate to the cash amount required to buy the new machine in 6 years' time? The top up. In order for him to raise this money of a top up in those 6 years of time, how much must he invest? Compound interest. So I talk about a compound interest condition. All right. Compound interest condition. So in our condition, A is equal to what? P into 1 plus I to the exponent of n. So what is supposed to be part of investment? That's the principal. Is supposed to accumulate to have this amount at the end. 363 305.5. All right, it was 51. There is a 51 here. All right, so that's equal to P. We do not have this P. All right, into 1 plus the interest 12.25, but compounded what? Monthly divided by 12. So that's 0.1225 over what? Over 12. To the exponent the number of years, the 6 years, but you must multiply by what? By 12. So that was the condition that was going to give us the money that is supposed to invest, the principal. So just divide these two part. So P is equal to everything here, 3305.51 over this whole part as it is. Just use your calculator on this case. All right. Just use your calculator to simplify or evaluate this. That was going to give us the principal amount that he is supposed to invest. And that was 174,857.32. So you must invest this in order to accumulate that amount over a period of 6 years. So remember, The issue of compound interest, you just put your money, then it increases as time goes on. It increases. It increases. Don't. It's not a monthly condition where you deposit monthly. You deposit once. All right. This one, it was a deposit of once. It's not of a future value or a loan that can be made where you are supposed to be paying monthly. This one, it is you deposit once, but it will be increasing along due to the interest rate that we are given. So that is how you can attempt these typical questions. You just need to play around, figure how these questions are given, and so on. On another part, 4.4, exactly 7 years ago, we are given that Krish deposited 25,000. That is the amount that was deposited into a bank. The bank paid interest at a rate of 8% per annum, all right, compounded monthly for the first 4 years. Okay, for the first 4 years. Interest rate was 8% per annum, compounded monthly for the first 4 years. Here, for the first 4 years. And then charged 12% per annum, compounded quarterly for the next 3 years. Okay? But along the way, we are told that Krish she withdrew 10,000 here, 3 years after making the initial deposit. 3 years after. 3 years after. So it means within the 3 years, within the 4 years here that we are given, that there is supposed to be an 8% compounded monthly as illustrated here. Before the end of that, before we even finish the 4 years, on the third year, she took 10,000. It happens. You are saving, then you take out from the savings. That is what happened on this condition of Krish. So calculate how much Krish has in the account today after the period of what? 7 years. As we are given this. All right. So let's figure out. Let's figure out. According to the information of a timeline, we can calculate these guys in different ways. It's up to you. You calculate amounts after each 0, 1. We start with 1, 2, 3, up to 7. All right? Or you just combine everything at once. So in this case, as for me, guys, I'm just going to combine. So try to understand me on my explanation here, because I'm going to combine everything. Okay? Remember, the deposit was 25,000. 25,000 was deposited. That's our principal. Okay? So let's talk about that deposit for the first 4 years. A deposit of 25,000 is being made into an account which gives 8% per annum, compounded monthly. So it had an effect within the 3 years there was a deposit. So meaning to say the 4 years is now subdivided to say we're going to talk about the first 3 years, then 1 year to make them 4. To make them 4, because the condition is they are under same interest rate. So we cannot separate it, that interest rate. So this is what I'm trying to say. A deposit, remember, compound interest. So we've got a deposit of what? 25,000. 25,000. Okay? This amount is accumulating. All right? So it's going to accumulate. That's an increase in terms of our compound interest. So it's 1 plus the interest rate, 8% over 100, which is 0.08 over compounded monthly 12. All right? So that's to the exponent of what? The number of years. Remember, we separated the 4 years into 3 because of what? Into 3 and 1 because of the withdrawal which was made in between. So we just separate that part to say the first 3 years under the same interest rate and compounding monthly, which is 12. So that's 3 times 12. The first 3 years before the withdrawal, because the withdrawal was made on the 3rd year. There was a withdrawal there. So let's take out our 10,000. This is the withdrawal minus 10,000. It's a withdrawal, this one. So whatever that we are going to have in our simplification, all right, let me put it this way. This one is going to be like, it's now affecting everything here because it is a certain value that is accumulated to in 3 years. Then we subtract 10,000 from that value. So it means this is within 3 years. So let's put this bracket like this. Within 3 years. This is for 3-year period. Because at the end of those 3 years, she had to remove 10,000 from whatever that he has increased into the bank. She had to subtract 10,000. Okay? But we are still left with 1 year which has got same compounding and interest. After she had removed this, there's a money that is left. This is the money left here. This is what is left. So what is left has to be affected by a compounding for that 1 year. What is left here has to be affected by a 1 year period after a withdrawal. Here, a 1 year period to cover the 4 years that are under an interest of 8. So that's, we're going to consider that. All right, so it was going to be 1 plus, as it is here, 0.08 over what? Over 12. Remember, this one is for 1 year. So the number of years, that is 1 times compounding of 12. This is now 4 years. The 3 years and the 1 year that we have here, this is 1 year. So we have covered 4 years now. This is what happened in 4 years' time, in a 4-year time. So this is the money that we are having in the bank now for 4 years. After 4 years, this is the money that is there here that we see here. So after 4 years, what happened? The compounding changed of the bank. It is now 12% per annum compounded quarterly. 4. So for the remaining number of years, 7 minus, which is the 3 years that we are having at the end, those ones, there is a certain compounding that is to be used. So we must consider a compounding for those 3 years. This money that we are having here, it is to be compounded. It is now affected with another compounding for the rest of the years, which is the 3 years that are remaining now. So we're going to have 1 plus, what is our interest rate? 12 over 100, 0.12 over what? Over 4. To the exponent of what? How many years that you are remaining with? 3 years times what? Times 4. So guys, Yeah, there are so many ways. But if you understand this, guys, you can answer a question direct because you can trace it. You simply have to trace your diagram. You trace it. So take note here, it is a single value. You must open a bracket that covers this one from 25,000 up to here, this one. Be very careful on the presentation of this. You close the bracket here. You must close the present that you see. The way that you see here, present it on your calculator as it is. All right. That was going to give us a value of, after this period, it was going to be 33,591. 593, sorry, 593,29, which is to two decimal places. So questions can be of that nature. Questions can be given of that nature. All you just need is to be very careful in terms of how you attempt the questions. So we need, actually on our finance, we are going to add more questions. It's unfortunate that we did not have a proper introduction. So we are going to try by all means work out introductions of our finance before the end of this term. For those who are still having exams that are ahead of time, we are going to try by all means to cover that part of finance. So make sure, guys, you understand all the basics from your grade 10 basics and this part of your timeline, which are timeline questions of this nature. They do ask questions like this, and there's so many ways of answering them. So pick a way that you are comfortable with, but at the end of the day, you must obtain same answers on our simplification. Then that is how these questions are actually given as. So that's on question number 5. We are given the sketch. That's the sketch below. Shows the graphs of f of x, and also there is the one of gx. All right. So if we are to study, this is the graph of our f of x from negative 90 up to positive 180. And that's 1 here. This is 2, negative 1, negative 2, and negative 3. All right. So let us just quickly go through the questions from the diagram that we are given or from this sketch. Okay, 5.1. That was write down the values of B and Q. B and Q. From where? From the graph of GX. Our GX, as we can see here, our GX is given. That is where we've got B and Q. All right, so that is from GX, which is equal to the cos of bx plus q, like this one. All right, so 1 is representing the amplitude there. It's to say the original amplitude was supposed to be 1, like originally. So there is a 1 already, so do not worry about that. That is why they are not putting any letter there to show that is a 1. So as for b, we can work out with what we had before, the periods, the period that we had before and the new period of the graph. So B can easily be determined using that concept to say the old period of a cosine graph, the graph of a cos, over the new period of the graph that we can see here. Because originally we do understand the graph of a cos is supposed to be cos of x. We understand the graph of a cos taken from 1 like this. This is the graph of a cos, which completes its cycle in 360 degrees. Thus, we are talking about the period 360, where it completes the cycle, complete cycle. This piece and this piece here, up to here, it is half, and there's another half, 180, 180, to give us 360. So remember that, all right? So here, guys, you know this. So that's 360, the old one. over the new one, as we can see from this graph. Where is it completing its full cycle? Like this one, the same cos graph here, we can see its shape. It is here, this one. This is the same cosine graph. Completing its cycle, that is, it's taken from 0 to 180. As you can see, half of the cycle here and half of the other one. It is completing. This time, a cycle is made in 180 degrees. A complete cycle is made in 180 degrees. The first half and the second half is made in 180 degrees. So that's our new period. So this was going to give us 2. All right, so that's our value of B can be determined. And Q can also be determined as it represents a vertical shift. This one. It is a vertical shift. To say how is the graph, how was the shift from the original to where it is? What was the effect? That was the shift. So you can work with the original graph, but it is another way of finding out the solutions to say from what we used to have, because our original was supposed to be like this from 0. It was supposed to be like this to 180, something like this. This is the original course. It was going to be completing on the 360. So we can see that when it is at 1, the new one is at 0. So it is shifted, going down. -1. When it is at 90, at 90 it is at 0, this one. But the new one is what? Where is it? The new one is going to be at this point, all right? Which is the difference between, all right? So that was the difference between, all right? So here it is giving us supposed to be effect of the bx, all right? So here it is going to be affected by bx, all right? Sorry for that. So this one was gonna stretch, guys. It was gonna stretch. It was gonna stretch in as much. So I'm supposed to maintain that stretch part like this, because we are not working with the original as is of this one. Y is equal to cos x. We are not working with y is equal to cos x because of the bx here, the 2. It is affected. So we are working with the original as y is equal to cos bx. So there will be a shift of what? -1. Each and every part. -1, -1, -1. So that's how we can play around. We have to go back to the original of cos 2x. You compare those two. The cos 2x, all right, and the one that is on the graph. But anyways, the other way, which is easier and which cannot bring any confusion, guys, is to take any point. As you can see, the gx, all right, another way so that we can use, we can take the gx. The gx is now equal to cos b. Our b is what? 2. So that's cos 2x plus q. So we can take any point, anyone, where the graph of gx is this one, any point on this graph. So we can use 0 versus this point, 90 versus -2, 1, any point. So can just take this one, 90 versus minus, it's a point which is found on gx, 90 degrees versus what? -2. It's a point. So substitute the x value, the y value, find the q, because that is the only missing part. So we are going to substitute. Remember, gx represents the y value, which is what? -2. So -2 is equal to cos of 2x, 2 times our x, 90 degrees, plus q. So let's simplify. -2 is equal to cos of 90 times 2, that's 180, and cos of 180 degrees is going to give us what? A -1. So that's -1 plus q. So let us find the q. From there we can take the -1 to the other side. So that's -2 plus 1, which is -1. So that's the value of q. Meaning to say our f of x, I mean our gx, the graph that we are given as the gx, we can substitute here. Let's just write it here. So therefore our gx, we can write it as cos 2x. Remember q is minus 1, so plus and minus, that's a minus like this. All right, let's just leave it. So the question is not about writing the functions, of about finding b and what? B and q. So this is our b and that's our q. Let's move on to another question. Write down the period of g. Remember the period of g, we already talked about this here. The new period of g, which is 180 degrees. So there, guys, we already talked about this. Then 5.3, write down the equation of h if hx is equal to this. If our hx, remember our gx, guys, is there. We have it. This is our gx. Cos 2x minus 1. So here they're simply saying hx. All right, let's have it here. Okay, our gx is given as 2 cos 2x minus 1. So they're saying the hx, which is the new function after the transformation, is now given as gx. You take the gx as it is. This is your gx. Cos 2x minus 1 as it is. Then you must add a 1. So when you add a 1, what are you going to have? So here it's just like 1 times everything, which is cos 2x minus 1 plus a 1. So minus 1 plus 1 cancels, that's a 0. So that's cos of 2x. So that's our hx, which is what? Cos of 2x. All right, so that's just simple like that, guys. You just have to work out as many questions as you can. All right, just try to work out as many questions as you can. So hx is equal to cos of 2x. Then on another question, calculate. It is not to determine where you can use the graph. Here they want you to exactly calculate the values of x for which this condition is equal to 0 for this interval. All right. When we are given that f of x minus hx, remember hx is this one that we just calculated now. When we are given that this is equal to 0, guys, play around with this equation. We can take hx to the other side of the equation. It's a minus. Becomes a positive there. So it'll be f of x is equal to 0 plus 1, it's 1. 0 plus 2, it's 2. So 0 plus this is going to be hx. No effect there. So they are trying to hide with you, hide away from you guys to say, find the condition where f of x is equal. When you are given something like this, you know that I just take my f of x as it is. Where is our f of x? As it is our f of x. This is our f of x as it is. You take it. Sine x plus 45. That's our f of x. You take it because they are saying these two, they are equal. Sine x plus 45 degrees must be exactly equal to the hx. And hx is what? Cos 2x. Guys, they said calculate the values of x. You are back to your trigonometric equations. We're now back to our term 2, where we dealt with those trigonometric equations. How can we solve these? Are we going to use the double angles where there is x plus 45? Try to write the sine and the sine in the same way, the sine and this cos in the same way. So it is either we can change a sine to a cos or cos to a sine. Remember, from the complementary concept, the cos of x is equal to the sine of 90 degrees minus x. So when we are given cos 2x, when it is 2x, it will be sine 90 degrees minus 2x. So thus, we can replace the cos 2x with this, which is under a sine, anyone that you want. So sine x plus 45 degrees can be written is equated now to this cos 2x, which was written as a sine, complementary concept. So that's the sine of what? 90, the complement of angles, 90 degrees. 2x minus, that's 90 minus 2x. So if these two, they are equal, we can equate them. We can equate these two. If they are equal, a sine to a sine. So it simply follows that this part of x plus 45 degrees is exactly equal to this part also, because it is under a sine, which is what? 90 degrees minus 2x. But remember, a sine, as you consider it, there are also other solutions which can be obtained. That's where you consider the issue of the general solution for a sine. When you consider this 90 degrees minus 2x, this angle here, it actually represents an acute angle. This is an acute angle. So when it is an acute angle, that's we are talking about this as our reference angle. So it means x plus 45 is equal to the reference angle plus what? 360 degrees times k, the general solution, so that we can have the part of our general solution here plus 360 degrees times k. So that can be our first part of the solution. But remember, when dealing with a sine, there is another solution, which is 180 degrees minus the reference angle plus 360 degrees times what? Times k. So thus we are going to have two solutions. Another solution will be taken from the same part that we had here, x plus what? 45 degrees, which is equal to, so we are going to need 180 minus the reference angle. Remember our reference angle, the acute angle, 90 minus what? 90 minus 2x. So that's our reference angle. All right. Plus, this part remains as it is. 360 degrees times what? Times k. So remember, k representing the integers. So that is how you can play around. So there are two possible solutions. We can work out from this side. We can work out from this side. So let's start with the first part here and see our solutions at the end of the day. What are we going to have? So that's collect the part of x minus 2x to the left hand side. Once it crosses, going to be positive. X plus 2x, which is 3x, all right, is equal to, we take the 45 to the right hand side, that's going to be a negative there. So 90 minus 45, which is 45 degrees plus 360 times k. So that is it. We can even find this, divide by 3 each and every term. So our x is equal to 45 plus, that's 120 times k, like that. Okay. So what will be the exact values for that interval from 0 to 180? From 0 to 180 degrees, we can test our values. As we can see, if we put negative, it's going to be negative values. So let's not work out with negative. Let's start with 0, 1, 2, and c. So when our k is 0 here, we can see that x is equal to 45. All right. Or if our k is 1, we can substitute a 1 here. That's 120 times 1, which is 120 plus 15, which is 135. So it can also be 135. When it is 2, 120 times 2 is going to be 240, which is already out of the interval 180. It is out of the interval. So meaning to say, for 2, there's nothing there. We're going to get this one and this one. So this is what we are having from the first part of our solution. Remember, there are two. We said it can be this, or it can be taken when we consider 180 degrees minus what? Minus the reference angle this side. So let's see what was going to happen on this other solution. Let's see, x plus 45 degrees is equal to, expand this by negative, that's negative times 90, negative 90, negative times negative, positive 2x, that's 360 times k. Okay, let's collect the like terms. The 2x to the left-hand side is a negative, so it's x minus 2x, which is what? Minus x. All right, we take the 45 to the right-hand side, so that's 180 minus 90, which is 90, then minus 45. So that was going to be 45 degrees plus 360k. All right. So this is where we are. So to find x, this is negative x. So to find x, we have to divide by a negative, a negative, a negative. So that is x is equal to negative 45 degrees, negative 360 degrees times k, like that. So for the values of k, we're gonna try 0, negative 1, negative 2, positive 1. We're gonna see that all these values will be outside of the given interval. Remember, our x from what? 0 to 180 degrees, as we are given before. So when you put a negative 1, this will be out of interval. When you put a 0, it's going to be a negative 45. When you put a 1, it's going to be giving negative values. For the positive values that you get when you substitute a negative, they're out of the interval. So there's nothing from this side. All right. So from this solution that we are given, there's nothing. All right. But this part, remember, we obtained solutions here. So therefore, these are the two solutions. So therefore, these are the two solutions. X can be 45 or 135. These are the ones that are within the given interval. So in exam, guys, do not just work out the first part, then you leave, you say the next one is not. It is because of the interval that you're given. The interval. All right, let's check another part on question 5.5. Now they say use the sketch. So this condition is not for you to calculate. You must use the sketch this time. Use the sketch to write down the value or values of x for which this condition do exist, this one. Okay, let's see the condition that they're talking about. Half of f of x, all right? So that's 5.5. Half of f of x times 4gx is equal to negative 2. So as we can see from the graphs, we just have f of x and gx. There is nothing like 2f of x or half of f of x. So let's simplify it until we see the f of x and the gx properly. So what is affecting half of 4, that is 2. Then we can divide by what? By 2 by 2. This one cancels. So we are left with f of x. We want to properly see f of x multiplied to gx. So that is equal to what? Minus 2 over 2. That's what? A negative 1. So as we can see, we need a condition where this exists. When you take a value from f of x, you multiply it to a value which is on the graph of gx, you must get a negative 1. Where are we having this condition? So that's why they said use the graph. You must look from the graph. You must consider the graph. This is our graph. Where is it that you take a value on f of x? All these are the possible values of x as long it is on f of x, the y value of f of x. You multiply it to the y value of this graph of gx. When you do so, you must get a negative 1. Which condition is it? So you trace along the graph. Product. If you take a value, as you can see, there's nothing visible here. So there's nothing here at minus 90. This is minus 45 degrees. There's nothing. This is 0 here. This is minus 1. So if you multiply 0 times minus 1, you cannot get a minus 1. 0 times negative 1, that's a 0. If we move at 0 degrees, F it's 1, G it's 0. So that's 1 times 0, which is what? Which is a 0. There's nothing there. If we move on to 45 degrees, on F of x is what? Is at 1. F of x corresponds to 1. Gx here corresponds to minus 1. 1 times minus 1 is what? Minus 1. So this is happening for us to obtain a minus 1 when the two graphs are being multiplied. It occurs when we are at what? 45 degrees. So x is supposed to be 45 degrees. All right, let's move on. 90 degrees, as we can say, that value and that value, guys, there we cannot have a minus 1. At 135, after this, we're going to have 90. We add this one, it's 0. There's nothing. There's nothing there. So the only condition where we get a negative 1 on the product to say what you see on the y value on f of x to what you see on the y value of gx, you multiply the two, you get a negative 1. It only happens when x is what? 45 degrees. Remember, this is 0, this is 90, so in between, that's what? 45 degrees. That is the condition. Where does it occur? So the condition here occurs when our x is what? 45 degrees. This is the condition where the product of the graphs is negative 1. All right. Considering the other part of the question we are given in the diagram on question number 6. ABC, which is a triangle, is drawn with the C on the origin. So C is on the origin, 0, 0. Coordinates of the origin. So use the diagram on diagram sheet 2 to prove this, all right? So this is what you're given. They just repeated this as it is. To prove this formula from our cosine rule. So they can give us a question like this to prove the cosine rule from a Cartesian plane. So when you're working with this condition of a Cartesian plane, try by all means to find the length between the 2 points. Remember your distance formula. When you are given 2 points, we can find the length of AB, we can find the length of BC, we can find the length of AC. So you use that concept. So as we want to prove for C, side C, this is angle C, this is side C, opposite this one. So we are supposed to prove or work out with the side C, meaning to say we are supposed to put our focus on the length of AB, the length of AB, the length of AB from points. So you work out the length, all right, of AB, where we have got C there, the length of AB, all right, work out the length of AB from what? Distance formula. So you can simply use our distance formula. All right, from distance formula. So in this case, we are supposed to apply the distance formula. Thus, we must have points A and B. We must have these points. At A, what are the coordinates? X value and the Y value. In the x-axis, we know that Y is equal to 0. So what is the X value? Because we know Y is 0 there. What about the X? The X is the length of this line. And the length of this line is the B. Remember, just like this one, angle C, the side is what? Is C. So this is angle B, so this is side B. Just like Angle A, this is what? This is side A. So we are saying the length of CA from C to A, it is B. The distance, the length from C to A, it is what? B. So that's the X value is what? Is B. It will be corresponding to B. So our X value is what? Is B at A. And at this point B, we also need the X value and the Y value. From where? Where are we going to get it? The X at B is the distance being taken, all right? If we take it this way, to the ground, like this, all right? Let's forget about this B that we talked about. The distance from C to here. So this will be perpendicular. This distance from C to this point, the value that is here, that's our X value at B. Then the distance going up vertically corresponds to the Y. So we must find these, our X and Y. As we can see, we formed a right angle triangle. So to have this, this is our X, this is our Y. X horizontally, Y vertically. So let's find these with this right angle triangle that we have formed. So from the right angle triangle, let's concentrate on angle C, because we can see our formula, guys, angle C, not A. Don't focus with that one. Let's focus with what? Angle C. According to the right angle that we have formed here, there is angle C. We've got a right angle. So according to angle C, Y is the opposite. X adjacent. So remember your ratios, trigonometrical ratios, SOHCAHTOA. So let's quickly have our SOHCAHTOA concept. The sine of what? Angle C. Opposite hypotenuse. As we can see, there is what? Opposite there, which is Y over hypotenuse, which is A. So as we need the Y coordinate, so let's find Y. They cross multiply. That's Y is equal to what? Y is equal to A sine C. Okay, so we have got this one, A sine of C. All right, that's the sine of C here. Then we can also consider the adjacent and hypotenuse. So adjacent hypotenuse on what? Cos. So that's cos of C is equal to adjacent, which is X, hypotenuse, which is A. So let's find X simply. Cross multiply. So X is equal to A cos of C. So this is our X value. A cos of what? Of C. So thus we've got a point. We just needed X and Y there to have a point. So let's use our distance formula now to prove or to work out this. So the distance formula states that the length of AB is equal to the square root of what? X values. So if it is x1, we're going to consider the x at A minus the x at B. Or you can consider this as x1, this as x2. Or you can say x at A minus x at B. So that's x at A minus x at B squared. Plus the y at A minus the y at B squared. Remember this part. So let's find this. The length of AB is what? That is the C. So meaning to say where we write AB, we're going to write C is equal to the square root of x value at A, which is what? Which is B. Minus the x value at B, which is what? A cos of C. But it must be squared. Plus the y value at A, which is 0 there, minus the y value at B, which is A sine of what? Of C. That's being squared, just like that. So we can simplify this part. All right, so C is equal to the square root of what? So if we take note here, there is the concept of our A minus B squared. Remember, it is equal to A squared minus 2AB plus B squared. So here we consider this as our A, all right, and this as our B. So if we were going to have A squared, that is, we are talking about B squared. So that's B squared minus 2AB minus 2 times our A, which represents B. Our B is represented, like we're saying, this is our A, this is our B. Our B is represented by what? A cos C. All right, so it's going to be minus 2AB cos C, minus 2AB cos of C. All right, cos of what? Of C. And the last part is B squared. Our B is represented by this. So it's A cos of C squared. That's A squared. And the cos is also squared. So it's going to be cos squared C. Okay, so we have expanded the first part. Yes, the second part, we can use the same situation. But guys, just take a look here. 0 minus 1 is minus 1. 0 minus 2 is minus 2. So 0 minus this, it is going to be minus A sine of C being squared. So when you square this, it's just going to change to a positive. So that's A squared sine squared of C. All right, that's the effect. Do not, yes, you can expand those brackets. You're going to simply obtain the same answer. All right, so this is where we are. We applied our distance formula, expanded brackets. Let's simplify further. We can even get rid, as you can see, guys, here it's what? C squared. So let's just get rid of this square root. All right, so we must square both sides so that we have got what? C squared. So C squared is equal to what is under the bracket, under the square root, which is B squared minus 2AB cos of what? Cos of C plus A squared cos squared C plus A squared sine squared C. We just removed that square that we are given. But as we can see, there is something common here. A squared, A squared. So let's factor out that A squared. So if I factor out the A squared, which is common, it means I'm going to remain with cos squared plus sine squared. So that's cos squared C, cos squared of C plus the sine squared of C. If we factor out A squared, all right, here, factor out. So these ones, they remain as they are, the B squared and the minus 2BC as it is. So that's minus 2AB cos C, sorry, minus 2AB cos C. So this is where we are. From our identities, we can see that we've got a Pythagorean identity there, which tells us that cos squared plus sine squared is what? It's 1. So 1 times A squared, that's A squared. So it's going to be C squared is going to be A squared times 1, that's A squared. This part remains as it is. It is not affected by anything. So that is what we were going to have at the end. As we can see, that is our cosine rule of calculating the side C exactly the way that it's supposed to be. But there we are supposed to prove it from that Cartesian plane concept. So it's another part that we can use to prove this type of a question. Just try to do as many questions as you can, guys. You see, exam, when you're in exam, you study the question. Is not just about what you have learned. What you've learned can be limited. So you must extend your knowledge. That's exam, all right? On another part, we are given in the diagram below, there is a right-angled triangle, which is ABC. ABC is right angled at B. All right. And also we are told that AC is perpendicular to DC. These two lines, they are perpendicular. That's at 90 degrees. Okay. So that is what we are given. Okay. So with this information, we are also given the length of AC, length of CD, and the angle BCA, which is this one. Then calculate the length of BD from B to D. So if you are to note here, BD was supposed to be calculated from triangle BDC. All right, BD from triangle BDC. It was supposed to be like this. All right, there is a straight line, something like this, something like this. This is our B, this is our C, and this is our D. So we are given the length CD, which is 10, and the angle BCD is a combination of these two angles, 90 and 26.57. So you add these two. It was going to be 116.57 degrees. Add these two. So you must add these two, 90 degrees to this one. All right. So that's our angle C, this one, BCD. So as we can see, we do not have this side so that we can determine the length of BD using the cosine rule. Can use the cosine rule. So, but we do not have BC. So we must calculate BC first. From where? If you consider the right angle triangle ABC, this one, it can help us to calculate BC. So we must find BC from triangle ABC, which is a right angled triangle at A, B. That's we've got ABC, right angled at B, with angle C inside of this triangle. The angle C is inside 26.57. It is inside of the triangle. So that's it. And the length of AC, which is 15 square root of 5. So you can determine the length of BC here. In a right angle triangle, back to your trigonometrical ratios, that SOHCAHTOA concept can be used. Where there is what? BC represents adjacent and hypotenuse. That is what you're given. So adjacent hypotenuse, that's what? A cos. So the cos of 26.57 degrees is equal to adjacent over hypotenuse. What is your adjacent? That's your BC over the hypotenuse, which is 15 square root of 5. All right, so let us calculate the length of BC. This was just an issue of cross multiplying. So that's BC is equal to 15 square root of 5 times the cos of 26.57 degrees. All right, so that's you and your calculator, guys. You were going to obtain the length of BC to 2 decimal places, which is 30.00, which is approximately 30. So that's 30 units if you round off to 2 decimal places. All right. So with that BC, we can determine the length of BD because we've got this BC, 30 units. So what is the length of BD? The one that we are being asked on our question. Remember, the question is we are supposed to calculate what? The length of BD. So that is our condition. Length of BD. The length of BD. So we can use our cosine rule. Remember the cosine rule, we have already written it. This cosine rule is up to you here, or you can go back to your understanding of a squared is equal to b squared plus c squared minus 2bc cos of 8 is up to you. The way that you are having there. Or you can work this one. What is important is that side to be calculated, which is BD, supposed to be BD squared, is equal to the two sides that are creating this angle. So that's CD squared plus BC squared minus the 2 times those sides. CD times BC times the cos of the angle opposite facing the side that we are calculating, which is our included angle. That's cos of angle C. So that's it. Let's substitute CD. That's 10. So that's 10 squared. BC squared, that's 30. All right, minus 2 times the product of these 10 and 30. And the cos of the included angle, 116. 57 degrees, just like that. So that's BD squared was going to, if you simplify everything, that was going to give us 1268,37 4509. All right, then you can just introduce the square root to determine the length. So that's our BD was going to be 35,61 to 2 decimal places. So we have got the length of BD that is being asked there. So you see, it is not always where the diagram is direct, where you just have to answer that BD with a certain formula. Adjustments are supposed to be taken. Remember your grade 10 mathematics when you're dealing with trigonometry, trig ratios. You use that in a right angle triangle. Find whatever length that is missing, which is useful to the other triangle that we must work with. In our case, we are talking about the length of BC, which was missing for us to use triangle BCD. So this is how these questions are given. All right, so that was it, guys, for a full paper that we had. Let us just continue to revise as many questions as we can, as we are preparing ourselves for the exams that are ahead of time.